Zach.
Okay, so this will be for the second day of 5-1. This is still operations with polynomials. Everything that we did yesterday was basically I split it up into the monomials. We did all the rules for the exponents yesterday. Today, the first thing the author goes back and reviews definition-wise for a monomial. Remember, a monomial is a number. Like if I just say the number 5, that is considered a monomial. It's also called a constant. It can be a number. It can be a variable. Like if I say x, x is considered a monomial. Or an indicated product. Remember, product means you're multiplying. An indicated product of a number and one or more variables. And when I taught this before, that's where we stopped. It just said a number, a variable, or an indicated product of a number and one or more variables. They've added to this definition with non-negative integer exponents. So for it to be a monomial, your exponents have to be from the set of integers. So the set of integers, remember, 0, 1, 2, 3, dot, 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 negative 1, negative 2, negative 3, dot, dot, dot. So you can't have like an x to the 1/2 power. You can't have like an x to the 1/3 power. Okay? Okay, so examples. Monomials. 2 is a monomial. Negative 5 is a monomial. X is a monomial. Negative 8x squared is a monomial. 9xy cubed, because that's a product of a number and one or more. As long as those exponents are non-negative integer exponents, those are all monomials. Okay. Then the author also goes through when are they simplified, when it says to simplify a monomial expression. So a monomial expression is simplified when, and then put a colon. Okay, these four things. Number one, there are no powers of powers. So you can't have a raising a power to a power. Number two, each base appears exactly once. So you can't have like a x appearing more, like I can't have like 2xy to the third x. Okay, that's not simplified. Okay, you would go ahead and take it to 2x squared y cubed. That's okay. So this one would be wrong. The third one, all fractions are in simplest form. And those of you that are new to my class this semester, we reduce all fractions. National Reduced Fractions Day was last August. Okay, all fractions are in simplest form. So, like, if I said, if I had like 10x over 12y, that's not, and that's not a monomial, is it? No, because it's a division. Okay, so that wouldn't be right to begin with. But if I said 10/12 xy cubed, okay, that would still be wrong because the 10/12 is not reduced. Okay. Yeah, if I went to 5/6, I'd be okay. And the fourth thing, there are no negative exponents. So you can't have any negative exponents in your monomials. Okay, then we've defined a monomial. The prefix poly means many terms. Poly means many. So a polynomial means many monomials added or subtracted together. So many monomials added or subtracted. So if I said like 5x plus 3y squared minus 2z cubed, okay, those are all monomials and they're added or subtracted, so that fits the definition of a polynomial. Okay, then the author goes through the degree of a monomial. Is the sum of the exponents of its variables. So if I gave you the example negative 7x squared y cubed z, and that's a monomial, and I said what's the degree of that monomial, you add the exponents. And if it's z, it's understood to be z to the first. Okay, so add the exponents, so the degree of this would be 6. Okay? On monomials, you add the exponents. The next one they do is the degree of a polynomial. The polynomial is many terms, so the degree of the polynomial is the degree of the monomial with the highest degree. So you look at each term. So if I had an example 8xy plus 27x to the 8th y to the second. Okay, I would first figure out the degree of this one would be 2. The degree of this one would be 10. So the highest of those is 10. So this degree is 10. So you take, on a polynomial, you take the degree of each term and then choose the highest one overall. Okay? Okay, then they will give you problems like this. Just the exponents. Just the exponents, yep. They will say, example, determine whether each is a polynomial. So on that, they're just asking yes or no. Is it a polynomial? If it is, state the degree of the polynomial. Okay, so find out whether or not it's a polynomial. So, example, say they give you c to the 4th minus 4 radical c plus 18. First, is it a polynomial? Are those all monomials with integer coefficients? Or integer exponents, I should say? No, this one is not. Radical, any radical, if it's a square root, is to the 1/2 power. I don't think you guys have had that yet. Did you have that in Algebra 1? Okay, so this one is the one that throws it off, because this is actually c to the 1/2 power, and that's not an integer. Okay, so this one would be, just say no, it's not a polynomial. Yeah. They're going to ask yes or no, so just say no. It's not a polynomial, and that's all you have to do on that one. Let's say they give you a negative 16 p to the 5th power plus 3/4 p to the 2nd power q to the 7th power. Okay, is that a polynomial? Yes. Each monomial is a number or a variable or an indicated product of a number, and are all these exponents positive? Yes. This is a polynomial, so this would be yes. It's okay if the number in front is a fraction, that's okay. What can't be a fraction is the exponent, okay? So this one would be yes. Now you have to figure the degree. What's the degree of this term? 5. The degree of this term? 9. So the degree of the whole thing? 9. Okay. Okay, and then the last part, they're just going to give you problems to simplify polynomials. We simplified monomials earlier. Now they're going to give you polynomials. So, example. And you got to pay attention to the parentheses and the signs in between. Say I give you the quantity 2a to the 3rd plus 5a minus 7, close the parentheses, plus the quantity a to the 3rd minus 3a plus 2. Oh, wait a minute. Change this. One more thing. Go back. Change this. That's a minus sign to start. That's my fault. Okay, now, depending on how you learned this in Algebra 1, you can do it the way you did it in Algebra 1. You can think of this as minus, you can think of that as a negative 1 there, and multiply that out. Or you can distribute that sign and say that would change that to a negative. A negative times a negative, that changes that to a positive. A negative times a positive, that changes that to a negative, and you're back to adding. Okay? So, 2a cubed plus a negative 1a cubed, just a cubed, plus 5a plus 3a, plus, just, yeah, the variable stays the same. I'm just simplifying up like terms, yep. So I'm simplifying this one to this one, and sometimes it helps to that one, and then this one to this one. So negative 7 minus 2, or plus a negative 2, be minus 9. And I don't care on these if you write minus 9 is the same thing as plus a negative 9. Okay? Okay, so subtraction, you can either think of that as a negative 1 or... okay, think of that as a negative 1 and multiply it out, or think of it as subtraction. Okay? That's how you probably learned it in Algebra 1. Okay, the quantity 4x squared minus 9x plus 3, that quantity plus, this one's a plus sign, the quantity negative 2x squared minus 5x minus 6. So combine these two, like terms. 2x squared, right? When you're adding or subtracting, yeah, keep the exponents the same. Okay, and then combine this one. Yep, minus 14x, and then minus 3. Okay. Okay. So if you're adding, and basically it's just a matter of Be very careful with your signs. Okay? Okay, last problem. The quantity a squared plus 3a minus 4 times the quantity a plus 2. Now, you can go either direction on this. If it was me, I would go this way. I would multiplying because there's no symbol in between. So I would take a times everything. So, and now you are going to have to work with exponents because this is like a to the first times a squared. Multiply the numbers in front. 1 times 1 is just 1. And add the exponents to be a to the third. And then multiply a times, so 3a squared minus 4a. Okay, and then multiply 2 times everything plus 2a squared plus 6a minus 8. Now you got to simplify. The a cubed, that's the only one that's alike. And then you can combine this one with this one. 5 plus 5a squared. And then you can combine this one with this one. 2a minus 8. Okay? Okay? Enough examples?
Yep.
Okay. Okay.